Sound speed.
Marker.
Action.
Check, check. Check 1, 2.
Son of a...
Sound speed. Action.
Hi everyone, thank you so much for joining us today for another True Audio Presents. We have an incredible show for you today. I got the boys from RF Venue here. How are you guys doing today?
Hey.
Awesome.
Everybody out there? Good to
Yep.
see you.
Awesome. And just so you guys know, we're here today to talk about the new RF Venue. This is called the Combine 8, but they actually have something called the 8-channel in-ear upgrade pack. And this is something that's going to change the game when it comes to IEMs, dealing with intermodulation and making sure that you can fit a lot of systems in a very tight package. So why don't we get into it? Adam, let's talk about this. Combine 8, how are you doing?
Doing great, Thomas. I wanted to thank you for having us on this live stream today. We appreciate True Audio support and happy to be here to help talk about our new product and also any existing product that we have that your customers might not be familiar with.
Love it, love it. Well, this Combine 8 is very special to me because I do come from a little bit of a live background as well. I loved being on stage, and I know that when you're on stage, you've got a lot of listening options. You know, nowadays it's not just, using wedges on the floor. You're using a lot more IFBs and IEM systems to basically listen and give people their personal mixes, which just adds a lot more wireless into the air. And we all know when you add a lot of things into the room, it makes it a lot harder, right?
Oh, yeah.
Yeah. Don, why don't you talk about that a little bit more? And in fact, why don't you even go in a little bit more about intermodulation, because that's what the Combine 8 is, basically the protector of. It really solves a lot of these intermodulation problems. So let's break down what it is.
Right. So intermod with radios is a little different. Most people are more familiar with audio and they know about intermodulation, and that was something that you got 0.001 of in your hi-fi system or something, and it kind of changes the sound a little bit. But intermodulation with radios, basically what's happening is when you turn a second transmitter on, those two transmitters together form additional channels that aren't there, right? So that's why they never let you use a cell phone in an airplane, because if 200 people turned on their cell phones, they would create millions of intermod frequencies. Phantom radio stations, you can measure them. They're on the air, they're just full of noise and garbage, and that means they're taking up what would otherwise be empty space, right? So basically everything we do with wireless, unless we have a license to lock down a frequency, we have to go find open space to play in. So that's what we do. We move around, we find a hole, and that's where we put our radios. So when you add a second transmitter and a third and a fourth and a fifth and a 20th, these things build up very quickly. So by the time you have 8 radios working together, you create like 40,000, and I mean literally 40,000 possibilities for intermod frequencies. Now, whether they actually happen or not depends on how much power you have in your radios and how close they are together, right? So if you're doing a scene and you've got 2 actors and they hug each other and they're both on wireless, at that particular instant in time, the intermod from those 2 goes crazy. And as they back apart, then it goes down. But that's why we're using wireless. People are moving around, things are moving around, all this is happening, and so we're creating intermod. It's coming and going. It's not that it stays there all the time, but you don't need much of a dropout to have a problem. So
exactly,
you have to be aware of all these things. So what we're trying to do is, through best practices, with your entire system, and you have to consider every radio that's on as part of the system. Sometimes I talk to people and they say, well, I'm using 10 wireless mics. Yeah, but I'm using comms and I'm using other wireless devices. So they all count together. They all have to work together because they're all working at each other to take each other off the air. So every radio that's on is interfering literally with every other radio that's on the planet.
Yeah, there's no bias. It's just kind of like King of the Hill. Whoever's louder and more powerful is just, it's got the waves, right?
Yep.
Exactly.
Yep.
So you've got to find a way. You need to have like a system. So I would almost say that the combined system is almost like that mediator that says, all right, everybody, chill out. We can all work in the same space. Let's all join together and play nicely, right?
Yeah, so two things. I mean, the reason that we're using this with all of your wireless stuff, the fewer antennas you can use, the better, right? If you can resolve all your wireless microphones down to a pair, an A and a B antenna, right, and all your comms, ears, all that stuff to a single antenna, assuming you can point it to where it needs to go. So, I mean, what you need to do is gonna change this. But as opposed to using multiple antennas on each transmitter, this combines, in this case, up to 8 transmitters, and then it sends it out to a single antenna.
Mm-hmm.
The other thing you said, that I want to go back and catch just a little bit, power, yes, King of the Hill wins, but when you power up, you're creating, so King of the Hill, that one most powerful device will win, and it'll greatly screw up all the rest of the devices, okay? Mm-hmm. So here's the thing about intermod. The intermod power grows 3 times as fast as the signal power. So that means if you turn up your transmitter by 10 dB, you turn up the intermod by 30 dB. It grows very quickly. So that's why we try to always use the lowest power that will work for us, because that by itself lessens how much intermod we're going to get.
Man, you know what? I'll tell you one thing, Don. That's something that I hope a lot of people hear and it resonates with them, because when we work in this industry, production sound, we're in the mentality of you got to get it. You got to get it the first time. It better not drop out. And so a lot of people, they have, like, even saying that, I go, whew, I got a little anxious. I'm like, I cannot drop out. And so the problem is that everybody just wants to go, well, I better boost that power up because bigger is better. And it's not. Minimalism is the key. You don't want everything competing, right?
Right. Yeah, you turn that power up and you might be good on that one, but like I said, you've now made it much, much harder for all the rest of the radios to work. So assuming you got to use more than one, the sum of your system is going to be much less.
Incredible. Incredible. Thank you for that demonstration and that example of what intermodulation is, because it really plays into what this Combine 8 is, and the fact that you have this whole upgrade pack and how it all plays together. And to furthermore, a lot of people, they might be saying right now, Thomas, we don't need to have 8 channels combined on a production sound set. And what I say to that is, not yet. But we need to, as a group, bring these new products in. So even knowing, yes, maybe this is maybe more geared towards live venues and things like that, I wanted to bring it in and say, what would everyone else in production sound use this for? This is a great piece of gear. We want to know what you would think. So definitely bring the questions in. In fact, we have a couple right now. Someone is asking, what is the difference between the Combine 4 and the Combine 8? Is there any big difference besides the channel count?
Primarily, that's the difference, the channel count. And the more channels you do, the harder it gets to do them, because again, there's intermod inside the box, but it's created in a way to minimize, to get the least amount of intermod you're going to get hooking 8 transmitters up to this.
Exactly.
So if you only need 4, then 4 is fine. We find a lot of people tend to need about 6. So for everything in the audio industry is in 4, 8s, 12s, and 16s. It's all multiples of 4, but for ears it seems like 6 is a sort of the average number that people are using these days.
Excellent. Guys, you know what? We have so many good questions coming in right now. What is the maximum input power per channel that the Combine 8 can tolerate?
Good question, because you have to do this right.
Mm-hmm.
So the Combine 8 was built to work with unlicensed devices, and unlicensed devices are limited to 50 milliwatts. So that's the maximum power you can shove into this. However, if you have the ability to turn down your power, you should. Well, I should point out something else. So we're looking at that big helical antenna. We'll talk about that in a minute.
Okay.
That antenna has a gain of 10 dB. So if you were to take your transmitters and plug into this, let's say you have 50 milliwatt transmitters, you would be much better running them at 30 milliwatts or even 10 milliwatts, unless you have to get somebody on the other side of a football field, okay? If you're dealing with great distance, then you do need power, and that's a different circumstance, and I know some of you, that's what you're gonna do. So in that case, that's different than if you're basically working in a combined, in a confined area on a set, on a stage, something like that, where lower power works. So if you turn your 50 milliwatt transmitter down to 10 milliwatts, you're turning it down, like something approaching 7 dB, but you've got 10 dB of gain on the amplifier. So you're actually more powerful in the air, but all the electronics have been combined at lower levels, and that's where the intermod happens, in the amplifiers.
Very interesting. So it's almost like people are trying to compensate when they don't realize that the gain actually needs to happen at the antenna, not here. You don't want to overload your output going to the antenna, right?
Right. Yeah, it's much cleaner. So it's funny, we talk about gain in an antenna. I mean, an antenna is a passive device. So when we talk about gain, what we're talking about is focus, right? So basically, the way gain in an antenna works, if we just have a normal whip antenna, the little whips, they broadcast in 360 degrees. So if you cut that power in half with a focused antenna, you take the back half that you're ignoring and you stick it in the front half, much like a cardioid microphone. In the case of the CP beam antenna, it's much more approaching a shotgun mic. We're making a much narrower angle of projection on the antenna. So in this antenna is basically transmitting roughly a 60-degree cone, right? So we're taking that 360 degrees and we're shoving it into 60 degrees. So it's like putting a megaphone basically in front of your antenna and limiting where it goes. That way you're not sending it to where you don't want it to be. There's no point, again, in sending things where you don't want them, much like the way you use cardioid and omni microphones, right? You want a cardioid microphone because you want to pick up in that direction and you don't want to pick up what's behind you, typically. So you pick a more directional cardioid, supercardioid, whatever the right thing is. But that's the same thing with antennas. So directional antennas, think of the way you think of omni and cardioid microphones. In the same way that a cardioid microphone will seem louder because it's more focused. So you're just capturing the sound in what appears to be amplified.
Excellent. People are asking, DC powered, does it only work with transmitters or can it work with receivers as well? So is this device DC powered? I guess that's the first question.
No, this device is not.
Okay.
This is AC powered.
A lot of juice going through it.
Yeah, you're going to have to use something that produces 110. It actually, the good news for us is that almost all the gear that you find these days has what's called a switch mode power supply, and they're pretty tolerant of getting any kind of crazy voltage. It doesn't matter. In the old days, if you had a 117 volt device, 110 volt device, 120 volt device, there's some audio equipment that makes a difference in. But these days, everything pretty much runs with a standard switch mode supply that'll handle anything from 90 to 240 volts. And likewise, as a general rule, I'm off the subject a little bit, but I get asked a lot too. You know, you'll see some things that require 12 volts or 15 volts or 14 volts, that kind of thing. You have a pretty good tolerance there as well, because most modern gear takes that voltage in, and then inside the unit it converts the voltage to whatever it needs to run on.
Right.
So a lot of times we'll get asked with wireless gear, some brands use say 15 volts, some brands say 12 volts, and almost always they're interchangeable. It just doesn't matter.
For sure. And you know what, there's somebody asking, can the device be converted to DC power? Most carts run on 12 volts. And in fact, I might want to help with this one as well. Just because it runs on AC and you have a 12 volt cart doesn't mean that you can't get some type of an inverter to go back to AC. You can get a pure sine wave inverter. People have been doing that for many, 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 many years. You just have to make sure that you get a good pure sine wave inverter to make sure that you get clean power into it. What Don is telling me by just the sounds of it is, you know, the combine 4, now we got the combine 8. It's literally math. You don't just shove 8 more things in the box. It's a lot of math and calculation to get everything to work right so you don't have those intermodulation issues. This is an intermodulation solving device, and it needs that power. So if you're putting 12 volts into it, how can that 12 volts be split out to 8 things without dropping in power? You need a higher amperage, so that's why it needs AC to be able to supply that steady stream of 12 volts up to 8 devices. Is that right, Don?
Yeah, this device uses a fair amount of power. To run it on batteries would be, challenging. You know, obviously it depends on how big your battery is, but you know, you'd be using up some amp hours quickly on this. So
for sure. Well, let's get back into a little bit more of the RF. Some people are asking, will the Combine 8 handle digital modulation IEMs such as the Lectrosonics Duet?
Yes, it will.
Awesome.
So there is no there's an issue with some of these units that use a
You
not
okay?
a computer on the front. Some of the very expensive combiners use it's like an automatic gain control. There's another term for it, and it just escapes me right now. But and those don't handle digital modulation well. We don't use that. So analog, digital, you can mix and match. You can run some analog and some digital units into the unit at the same time.
Wow, excellent.
When you do use digital, though, your spacing needs to be a little farther apart between channels. So that would be, for ours or anybody else's, that's just a good practice. So, yeah, but the unit will pass signal and work just fine with both digital and analog at the same time, if that's what you happen to have.
Yeah. What about amp draw they're asking about?
Well, that's what I was saying, that the current on this is a little higher if you were going to run it from a battery.
Better be a big battery.
It would drain your batteries, not instantly, but you know, you'd need you'd need physically large batteries. So
yeah, exactly.
So, yeah, for guys with a bag, you know, this is going to be inconvenient, but it works well. And the thing we should say about this, because we've all got budgets, is this thing only costs less than half of anything else that's out there. And we get that question all the time. Why is yours so much lower in price? And the only smart ass answer I have for that is you got to ask the other guys why theirs is so expensive. You know, we have circuitry that does the job. It does the job well. And you know, there's no reason for it to be more expensive the way we've built it. Now, I don't know what other people have done.
Exactly.
But you know, this comes in, that entire package with the antenna, cables, and everything is under $2,000, where almost anybody else making an 8-channel combiner starts at $4,000 just for the box, not including the $600 antenna and the rest of the stuff. So not including the DC power supply for the transmitters.
Right, right. You know, I
So,
think you answered this earlier, but another person's asking, can the unit handle 250 power like the Electro T4 system?
no,
No.
no.
Copy that.
That-
You're,
and
you're
that-
regulated to
that's-
that 50
well,
milliwatt.
that's part of the reason that the cost is down, because the vast majority of users, and maybe not so much you guys, because you guys do have license for a lot of these.
Mhm.
The vast majority of use for this kind of device is unlicensed.
Yeah. And
So-
again, though, like everybody has to remember is like, if you're really gung ho on just always running your system at that maximum power, maybe you need to reevaluate and just think about things a little bit. I'm not trying to be rude. I'm just trying to say that's not always the right way to do things. And that's why I've got
It's
our
always-
venue here to talk
it's
about it
always
today.
enhanced, right?
Yeah.
It's always trade-offs. If you run the ears at 250, you're making it much harder. You're making it much more likely your mics are going to drop out. So, I mean, we've all got, there's a money device out there every time. This one can't fail.
Mm-hmm.
And if you got to, if you got to have a problem, you may have to pick somebody at the end of the line, but that's a trade-off you're making.
Absolutely. So guys, so we've obviously talked a lot about the applications, and again, we do know that it's meant more for like, permanent setups or in a venue or something like that, something that can plug into the wall. I know people have been bringing that up. What's the maximum power? Somebody's asking. On the output, I'm assuming. They're asking, what is the max power? I don't really know how to answer that question, to be honest.
Yeah, I think that's what we just touched on. I think they're asking if you can put 250 milliwatts.
Oh, yeah, the maximum going into it, the maximum input power that it can take is 50 milliwatt.
The output is essentially unity.
Yeah, it's just whatever you put into it comes out of
Whatever you
it.
put in, you more or less get out.
Gotcha.
Give or take a tiny bit.
Okay, cool. Great questions, everyone. Please keep them coming, and let us know if you have any applications. How would you use this product, the Combine 8 and the upgrade pack? Yeah, let's talk a little bit more. So who else do you think this product is for? Because obviously, I keep saying venues and stuff, but again, I felt like bringing it in today because I thought, we do use the Combine 4 in our industry a lot. And like you were saying, just sometimes you just need one or two more channels. So having that extra is definitely beneficial to know about. That's why I wanted to bring it up today.
Yeah, and one of the things too, as with this COVID thing, we've seen a massive increase in people streaming things. And if you're working with somebody that's doing live music or anything where they're creating a reasonable amount of actual sound on the stage, having wedge monitors gets in your mix and screws up your mix. So having in-ear monitors when you're streaming is going to give you a much better chance at developing a really good mix that's going out over the air.
You bring up another point to me is that I see a lot of people in our industry that do, music playback or even mix minus sessions. If anyone doesn't know what a mix minus session, it's when you have like those FaceTime conversations with people where you've got the security guard that's talking to somebody in another country. Oh, what happened? And they're just having that conversation in between a screen. Well, sometimes those conversations, they get really complicated when they have 4 or 5 or 6 people on the screen. And the way that they film those is that you'll be on the same stage and each actor will have a camera pointed at them, but they're about maybe 10 to 15 feet away from each other. And in these types of situations, having a Combine 8 system like this is a perfect solution because like you said, you're eliminating all that bleed. I can only imagine being on stage, having all those wedges blaring up at you. It's the same problem that we have when you're on a very, very quiet stage. Even when you have 4 or 5 little speakers with mix minus mixes going to everybody, there's potentials for feedback going all back and forth throughout the room. By using a Combine 8 and sending all of your mixes to your talent wirelessly, you eliminate a lot of those feedback issues.
Right. Yeah. Nobody wants any extra junk in their signal, right? So
No.
that's a good way to help eliminate that, keep everything cleaner.
I love it. I love it. Guys, let's talk a little bit more about the antenna. We've talked a lot about the Combine 8 and all of the stuff that can go into it. It works with basically virtually any UHF IEM system. Is that correct?
Yeah. Let's talk about the antenna for a minute.
Let's do it.
So that's a helical antenna.
The CP Beam.
Yeah. If you're not familiar with a helical antenna, and I'm sure a lot of you guys are, but that's the one you see on the sidelines at the football game, the plexiglass, a half dome with it's got a tube and then it's got a copper coil around that. And
we used to call it the top hat.
Yep.
Yep.
So what you're basically dealing with is an antenna that it's a corkscrew, and so the signal coming out of that antenna is polarized at 360 degrees. So let's talk about antenna polarization, because this is one of those things that most people don't consider. So if you take a wireless microphone, so you take a stick and you hold it straight up and down from 12 o'clock to 6 o'clock. And let's just consider a whip antenna, just a little rubber ducky whip antenna. Okay, if we put that whip antenna on our receiver and we point that one straight up and down from 12 o'clock to 6 o'clock, at that point, the receiving antenna will soak up as much power out of the air as it's capable of doing, right? More expensive radios are going to do it better than cheap ones, but so that's going to be perfectly polarized. Okay, now if you take that microphone that you were holding straight up and down from 12 o'clock to 6 o'clock and you turn it out, shut a microphone, and you turn it out 45 degrees, right? At that point, the antenna will lose half of its ability to pick up your signal because it's not polarized anymore. That's usually not a problem. 3 dB, you still should be just fine. But the problem is that now if you hold that microphone straight out, the way a singer would, you're down 20 dB more on that receiver. In other words, you're looking at only picking up less than 128th of that original signal. You have lost the signal because your antennas are no longer polarized. Okay, so now with wireless microphones, that's why we use 2 antennas, and they've got to be positioned just right, but there's a way to solve it. But with ears, there are very few receivers that have 2 antennas. So they're mostly all single antennas. So as you're wearing that belt pack and you're turning and twisting and rolling and the polarity is always changing, and that's why for ears this is the solution. This is just the right way to do it. That's why we package it in the package this way. You've seen in that picture too. Oh, if you've used those other top hats, and you need a couple of them, you need a bunch of Pelican cases to carry them around.
You need a huge Pelican case.
Yeah. And if and you may need 3 Pelican cases in your truck, so you're starting to use up some real estate. Ours, the picture you had there, it folds down and collapses, and you can put it in a rack drawer even. So, in a Pelican case that would carry 2 of those top hats, you could probably put a dozen of ours, 16 of ours. I mean, just a lot.
You just smush them in and throw them in. It'd be like the snake in the can when you open it.
Yeah,
pop out, right?
That's what it is. Yes, and it took an incredible amount of engineering to make, a slinky, basically, a spring that can be collapsed tens of thousands of times.
Phenomenal.
And it just works. It's also very rugged, because let's face it, stuff gets knocked over. And if you have one of those plexi ones, 6-8 feet up in the air, and it drops on a hard deck,
it's done.
You're very likely to crack it.
Yeah.
Ours, you can't run over it with a truck, but it's a whole lot more tolerant of that kind of thing.
For sure. Someone's asking about the frequency range of the antenna. This is the 470 all the way up to 700, 698, right?
Yeah.
Okay, perfect. So it's, very wide spectrum, should be able to get everything that you need with this antenna.
Yep.
Mm-hmm. A lot of people are saying been using them since 2013, compact and effective. We'd love to hear that. Does the Combine 8 work for both receivers and transmitter units? This is just transmitters coming into this being pushed out, right?
Yeah.
Mm-hmm.
One's pitching and one's catching. So
Exactly.
no, it's just the backwards of what you use with wireless microphones, right? So
Now, do you have an alternative?
taking one signal in and splitting it to a bunch of outputs, and with this, you're taking a bunch of inputs and splitting it to a single output. So this is a mixer, right? You're just like you're running 8 microphones into it, and you're going to send that out to one line. In this case, you're taking 8 transmitters into it and sending it out to one line.
Very good, very good. So what would the opposite be for everyone asking if they needed the opposite of a combine 8, some way to combine all of their transmitters into one receiver filter thing? What would they want to get if that was the case?
Well, this is the one to get the transmitters into single.
I'm sorry, I meant the receivers, but I got flipped up now. Sorry.
You got just the opposite. Stand on your head.
Yeah.
So the other is an antenna distribution system, a distro. And with that, you take your A and B antennas in, and then you split that to multiple outputs. There you go.
And that's the Distro 4 right there.
Distro 4, which actually has 5 outputs.
Excellent. Excellent.
Well, when this first came out, it had 4. And then we added a 5th output, which we, instead of calling it output 5, we called it Cascade. And that's so that you could put a pair of these together and have more channels.
Like a daisy chain, right?
Yeah.
Okay.
So the funny thing is, so we have a new distro, the Distro 9, which is probably, so you have 8 outputs and a cascade into a second unit. But you can use that, Distro 4 does 5 receivers.
Very good.
The Distro 9 does 9 receivers. And you can combine Distro 4s, you can stack together to get up to 25 channels. Distro 9 you can stack together to get up to 81 channels of
Oh my
microphone.
gosh. Wow. Excellent. And guys, moving all along, these, basically what we're doing at this point is, we've talked a lot about the Combine 8, but I wanted to give everybody just a broad overview of all of the products from RFNU because they make some of the best wireless systems on the market. And, not even just the wireless, you even have something to help when the RF is just not enough. Talk to me just for a moment about this optics system. We don't have to go crazy on it because I know that we could literally do a live stream specifically about the optics.
Right.
But what is this for?
One of the problems with antennas is coax cable. You really can't get a good signal in a coax cable much more than about 200 feet. So what this does, this converts your RF energy. You plug it into this box, it converts it to fiber, and then you can put these 2 boxes up to 5 kilometers apart. I don't know anybody that's actually gone that far, but you could do that. So this gets used a lot for guys doing reality shows and stuff where if you're in a house, you got, a bunch of rooms and you got to get everything in minutes from this room to that room. You put antennas in all the rooms and then you run them back with fiber, which is very easy. A few hundred feet, 100 yards of fiber weighs 1.5 pounds. You put it in your back pocket. 100 yards of big LMR 400 cable, and you need a couple of angry guys to move it.
Yeah, I'm one of those angry guys. So heavy. Exactly.
No, it's very difficult, and it's expensive wire.
Yeah.
And there's something we should throw out at you. Your coax cable isn't expendable. Okay, I have microphone cables that are well past 30 years old, and they probably work at 99.8% of as good as they ever did. But every time you roll up a coax cable, you're wearing it out. So it's like tires on your car. Every time you go around a block, you've got a little less tread than the time before. And how much loss you can sustain and still work depends on your situation. If your cable's down to being 90% effective, might work all day long. 60% effective, might work all day long. In some circumstances, takes you off the air in others. So coax cable, the reason coax cable works is that it's perfectly round. And anything you do to make it, elliptical shape, if you step on it with a boot heel, if you roll a hand truck over it, if you stick it in the lid of a case when you're closing a case,
slam it shut, yeah.
And you crush that wire down a little bit, what actually happens it creates echoes in the wire. And when you get enough echoes in the wire, your receivers can't figure out what they're supposed to do, and they just say, we quit. So the more you use coax, the faster it wears out. And frankly, these days, as you know, wireless is getting much, much tougher, and it's going to get even more difficult to do tomorrow and 6 weeks from now and 6 months from now, especially because of 5G cell phone service is not your friend. It's great for your phone, but it's making your life difficult for wireless stuff. So
it doesn't cause COVID, but it's going to cause problems regardless on set, right?
yeah, everybody on set that's got an iPhone 12 in their pocket is creating interference.
Oh boy, fun.
And yeah, and I mean any brand of 5G phone, if they're on T-Mobile, you know, those pink lightning bolts are interacting, again, more radios. So even though they're not wireless microphones, they're very, very close to you in their frequency. They're not quite your frequency, but they're close enough, and there's enough power and there's enough of them that they create intermod down to about 550 megahertz. They will interact with you. So there is a way to fix that. Do you have a slide of our bandpass filters?
I think so. Stand by, looking for them. I just got to bring up the right picture. Bum, bum, bum.
Well, it's a little block. It's about the size of a. There we go.
Found him.
There we go. Okay, so there's these little blocks, and they're about the size of a pack of gum with a BNC connector on both sides. They're passive. They take no power. You just plug them in, and so they create a band pass. So looking at those two sets of frequencies there, as long as you can tune everything inside one of those band passes. So let's stop right there and hold. So as long as you can tune all your devices inside of 470 to, well, that one says 470 to 560.
You know,
so,
Paul, it's kind of like on a slideshow. It's hard to pause it. My apologies.
Oh, okay. Anyway, so as long as you fit inside one of these upper and lower limits, that's all it lets through, and it blocks everything else. So T-Mobile is starting at 617. It's above where you are. Even at 608, it's above that. And these filters will knock out, 99.8, 99.9% of T-Mobile interference. They will reduce T-Mobile interference by over 60 decibels. Mm-hmm. And so, that's something you're really going to need, especially if you're outdoors. Oh my God, you all know how much harder it is to work with wireless outdoors, because you have no protection from a building.
You have nothing helping to bounce around to have it get to an antenna. It's just, does it get to it or not? Yeah. One of the things that I love about this live stream that we're doing, Don and Adam, today is literally an RF theory masterclass, if you ask me. And I cannot stress enough, I just want to repeat it, how much I really feel like more than half of us that are watching, we might need to turn down our RF output power and, try a new practice, in these future years as things go on. Because if we're always revving that engine at 100% and just blasting it out, like you said, it's just wear and tear. It's just adding congestion. It's adding intermodulation. It's just adding more problems. So, and even the fact of these bandpass filters, I always like to tell people, bandpass filters are like having 100 people in the room when you only need to focus on 2. And by enabling that filter on those specific frequencies, you stop everybody else from yelling at you.
Exactly.
So, yeah.
Yeah. I should say one other thing about power, because again, especially if you come from an audio background, which I do, when you're looking at your receiver and you're looking at the LED ladder, how strong your signal strength is, believe it or not, you don't want 100%. You want to set up your system and tune everything in where you're getting about 80%, right? Because if somebody gets too close, it's gonna go up and down, right? So we never can stop the world and say this is what we're going to get, because people wearing wireless mics, they move, and as they move, their signal strength goes up and down. Everything
changes.
So the thing you don't want to do, you don't want to you don't want to overload the front end of your radios. They go bad in a hurry. So you don't want you don't need to get full green lights. You know, if you've got five green lights on your receiver, you really want to set your system up so you're coming in on the fourth one, because occasionally you're going to hit the fifth one, and we don't want to go any farther than that. Like radios overload, kind of like digital distortion does. You know, in the old days, we were all analog. Yeah, you could go past, you know, whatever it said your limit was, and it just got a little, you know, it changed the character of the sound a little bit, but it didn't destroy it. But with digital, of course, you know, the second you go over, you go from being perfect to being perfectly unusable. You know, you just, there's no smooth transition. So you want to keep that down. Also, you don't, I have a lot of guys in this biz that use amplified antennas, powered antennas,
Yeah.
or they use line amplifiers in those antennas, and those are not your friend. They do not increase distance, and in fact, they lower your carrier to noise ratio, right? So what makes your wireless mics work, and your ears, which are just wireless mics, is that you're able to get your signal from your transmitter, your carrier, back to your receiver at least 20 dB hotter than whatever the noise floor is where you are, right? And at that point, so we're talking about how close our toes are to the edge of the cliff. And if you get 20 dB above the noise floor, most times, it depends a little bit, that should be comfortable. Now, I'd like to have 40. I'd like to be a lot farther away. You know, if you're 2 inches from the edge of the cliff, you're going to not fall off the cliff, but it's kind of hairy hanging out there. I'd much rather be 20 feet back from the edge of the cliff, right?
Right.
So you know, you need to get that signal back above the noise. When you use an amplified antenna or you use an inline amplifier, you lock whatever your carrier to noise ratio is. And so if it's a 10 dB amplifier, yes, you raise your signal by 10 dB, but you raise your noise by 10 dB. So unless you're have a very, very hot signal or a very, very weak signal, if you're anywhere in the middle, if you're anywhere in the normal world, this shouldn't matter very much at all. The absolute voltage doesn't matter. What matters is the dynamic range, the carrier to noise ratio.
Wow.
So if you get that right, you know, that's what you want to do. So that's where you want to use better cable. That's where you want to use the optics system. You know, when you're trying to do sound and you're laying coax across a golf course or something like that, you know, you don't want to do that. You will get much better performance by not having amplifiers in that signal line.
Very good. You know, we have a couple more questions, guys. One of them is, with 8 transmitters running, how do we get the best results for gain control selection? And in fact, some people are asking, does this unit utilize automatic gain control?
So no, it doesn't. So you're going to get what you get, right? So you'll have to do, you know, if you're sending out 8 monitor streams, that's coming from a mixer or, you know, somewhere probably. Mm-hmm. That's where you would control it. Yeah, the AGCs screw up the digital signal, right? So if I was doing this with a mixer and I wanted something like AGC, what I would do is I would just drop a compressor in that line. Do it while it's still audio.
Gotcha.
Because it doesn't like to be done to digital signals.
Okay, copy that. That's a good question. And we have another one saying, are there any portable or consumer-friendly coax measurement tools?
No. That's the problem. You can go on YouTube and people tell you, get your multimeter out and check. And unfortunately, it takes like an $8,000 box to check a cable. Mm-hmm. It's called a vector network analyzer. You can't measure it. Your multimeter is going to tell you that DC passes through the cable, that it's not broken. I mean, obviously that would tell you have a complete failure, but what you're really interested in is the performance level. So at 500 megahertz, and your tester won't test for that. So no, nobody has them. I don't know where you could take them and have them measured. You just kind of have to. There isn't a good answer, unfortunately. Mm-hmm. You just have to kind of keep replacing your cables periodically. I don't know if that's once a year, once every 2 years, once every 6 months. Again, it always depends how mission critical something is and what the budget is. But that's the way it goes.
All right, we got another question, and usually when I hear one of these manufacturers, it can be political, so I just want to make sure that people understand that Combine 8 does work with analog and digital transmitters. Does it work with Zaxcom, who is a digital system as well? Will it play nice when you have analogs with Zaxcom?
Yes. Yeah, no problem.
Beautiful.
Yeah, I mean, we don't make the radios, so what we have to do is play nice with others, right? Mm-hmm. So we're always using somebody else's radios. And
can you break it down? Why do people get worried about the Zaxcom digital transmission and analog? Like, why is it that they don't necessarily play nice with other systems? Not the Combine 8. It works perfectly with the Combine 8. Why not with other systems? Do you know why?
Other wireless systems?
Yeah, like why would Zaxcom digital transmission and like an analog system maybe not? Like a lot of people get very nervous when they say, oh, we want to take an analog and a Zaxcom and put them in the same workflow. People get very nervous about that. They, get worried. So the Combine 8 is going to help just make sure that there's no issues.
Right. So what we're working with a radio wave. And radio waves are all analog. The digital is the coding that goes on that wave, right? So digital radios essentially are sending ones and zeros out across a radio carrier, and analog FM is modulating the frequency of that carrier. But they're radio waves. Radio waves are they're an electrical wave in one direction and they're a magnetic wave in the other, and it's those two things together, I make a cross here, that create a radio wave. And so we're dealing with the signal level at the radio wave part of it. So it doesn't matter. All radio waves are analog.
Incredible. Guys, this has been great questions. If anyone has any questions about the Combine 8, please know that you can contact any of our True Audio locations. We have 5 locations, 3 in the U.S. as well as 2 up in Canada, and we would love to talk to you guys about this system and see how it would work with your systems. Guys, if you don't mind, I would love to end this with obviously saying thank you so much for being here today and showing us this, and Don for giving us literally a dissertation on RF mastery. Thank you. For everybody listening, I'm going to have to watch this again. So thank you, and I'm the one that made it. But I do want to ask, there's one more question. Somebody says, is there a simple way to improve signal reception reliability for a guy that's working out of a bag? I know that today we've been talking all about, cart-based setups and, full-blown 8 IEMs. But you know what? A lot of our customers, or some of them, are still working out of a bag on certain things. What can they do to improve their RF?
Well, the easiest, most improvement you can get would be to switch your antennas to our diversity fin antenna. And if you got it, there you go. Okay, so that diversity fin antenna, because it has antennas in 2 directions, eliminates polarity dropout. And polarity crossfade polarization errors and multipath, which is really the same thing, ghosts, is the polarization is eliminated in this antenna. That antenna will not drop out. Okay, it's plain simple. That antenna picks up the signal, and the signal will always come from that antenna down through your wire into the rest of your system. When you're using a pair of paddles, that may not happen. it doesn't go off the air very much, but how many times are you comfortable going off the air?
Never.
So with that antenna, I can tell you for the last 5 years, I walk into theaters, churches, every place. I unplug their 2 paddles, plug this guy in, and they just don't have any problems anymore.
Wow.
No, I'm not brilliant. The smarts are built into the antenna, and that's that's one of the 3 reasons that radios drop out. Range would be the other one. That one's pretty easy to understand. You can't get too far away. But crossfade polarization errors and multipath are the other 2 things that take a otherwise working system off the air. So this is great if you're working out of a bag, because you only got to put it up on 1 stand, right? You don't have to put up 2. You're still using 2 cables. That is 2 antennas, okay? But it just goes up on 1 stand, or if you're putting it on a pole, you don't have to have 2. So if you're not using this, and I'm sure you've seen this around a lot. There's a lot of guys using this because this just is a plug and play solution for most of their problems.
Absolutely. Absolutely. I've been using these for years. They've always been rock solid. You take off, like you said, take off the 2 fins, throw this up, and you're pretty much done.
Yep.
We have another question. RF diversity versus CP beam. Is the diversity superior?
Okay, so diversity is a receiver situation.
Yeah,
and
it's different.
Basically, your receiver has 2 radios in it, and you're feeding them both. So if you were using CP beam for your receivers, for your wireless mics, it would take 2 of them.
Right.
And that's what I would use if I've got to get somebody on the other end of a football field, coming towards me. If I had to make one really long shot with a great amount of distance, that's the antennas I would use. So it's just this one approaches the polarization issue in a different way. It does it by circular polarization, where the diversity fin does it by having the antennas are orthogonal. So you've got one at 90 degrees and one at 180 degrees.
Yeah.
And that takes care of it. They're locked together that way. So you can't screw it up. When you have 2 paddles, sure as hell somebody's going to move one for you. And what you had set up isn't going to stay that way.
For sure. I think what it comes down to, everyone, is that there is not one antenna to rule them all. There is multiple antennas, and they all have specific purposes. So what it comes down to is that we really need to understand this RF theory and technology as best as we can to be able to relay it to our clients and let them know that based on what they're doing, what's your product, what are we going to work on? And once you hear what we're working on for the production and you understand the complications of the process, then you can decide what antennas you need to use.
Yep, it's always the right tool for the job.
Yep, and even more than that, it's not the tool, it's the fool, right? I guess we'll end with that. Guys, thank you so much for joining me today. And everyone, great questions today. Hope you like it. What do you think of the Combine 8? Let us know in the comments before. Thank you so much, guys. Keep it coming.
You bet. Thanks again.
Awesome. All right, guys, we'll talk soon. If you guys have more questions, leave them in the comments. I'll get them answered from RFNU as we go along throughout the day. Take care, everyone. Have a good one.